All right, so we're getting ready to weld on the second side. Here is my clamping setup. You can see it tilts down just a little bit because that's the way the metal is, but it's not too bad. So first we'll do a couple plug welds, then we'll do a couple tacks, then I'll get the clamp and stuff out, or maybe put a bracelet. We'll see. All right, now we get to the fun part. Now it's going to start looking like it's moving a little bit. Well, not really moving, literally, but soon. All right, we now have a plan. So we know that the axle position there was just slightly front heavy, but not very much. So I'm going to maintain that same position for the mounts. These are what I'm going to use. These came off of the wheelchair or the power chair. So these are going to give me the pivoting motion of the front. I know what the height is, the 12 3/4. That height right there is what I need to maintain. That whole unit there is going to be kind of weight independent. It's already balanced more or less with a known position on that axle. With those two combined, I want it to be fairly balanced over these set of axles. And that'll help keep the strain off of those mounts that I showed you in a couple videos back. So we're using a disc cutter to just kind of, we watched that and made a solid cut all the way down, and then we scored a pretty deep line, and now we can just bend this up, back and forth a couple times, and that will pop right off. Ow! We came up. So rather than creating new mounts, I just freed the ones that were already on the frame, sawed off the frame, came in, and then down, and I have a little bit of extra height on there. I don't think it'll be a problem. I can always go up on the frame, but that saves me a lot of time. Ow! This piece of angle iron will probably get welded in like this with the mount directly below it. I'm just going to do it solid. At the end of the day, simplicity wins, and I don't have to worry about the balance as much as I thought because I got the batteries that I can use as a counterbalance. All right, so for the alignment of the two things, I'm going to need a rod that goes across the two of them. It's a metric bolt size. I don't have it. So I'm going to use some all thread, and I'm going to make a spacer here that replaces the bolt. And we're doing some pretty deep hole drilling here. We've already turned it to size with dead center in, and now we're going through and we're boring it out and drilling it out until there anyway. One of the kind of neat things is if you can keep your feed rate right and the moons align, you can get it to eject some pretty long chips. And if it can eject these chips all in one like long chain here, then that is not clogging up the bit at the end because it's all staying together. So you can't really rely on that, but when it happens, it's a bonus. And if the chips don't eject and they start jamming up in there, this is what you end up with. And in case you're wondering why I'm going through this much trouble to reuse this mount instead of just having, say, two plates with the holes in them, butting up next to each other, that's kind of a fair point. But the thought is that this extra width and the tightness between a nice pin and the bearings on the inside is going to give this resistance to. So I'll have a nice smooth motion. I won't have the rattle. I won't have the wobble this way. And for something, you're going to have spinning blades out here that are like chewing through ice and snow. So you want a pretty good connection to the frame without much chattering. All right, so we're putting together bushing number 2. We drilled it out, and then we had to do a quick fore to get the right fit for our existing bushing so those aren't lost. We drilled out a couple fender washers because we needed something with a big diameter that was also quite thin to give it the proper spacing on each side. And now we're about ready to part it off. And, it's just slightly smaller, slightly on the inside because we're going on this inside diameter. So that didn't really set me back that much time, and it'll give me good results, I think. All right, so you can see it assembled. So the threaded rod allows me to clamp it with nuts on either side, and so that way I know for sure that they're both in the exact same line, and that I can adjust the width that they are very precisely so that they're each sitting like on the edge of the frame rail, so I can get as good of a welding spot as I can. So now that we've set the width, now we're going to clamp it into there. and see how it pans out, how we mount it to the frame. All right, so we know that these are wide enough to hit the right spacing, and we've marked their center line, and we've marked the center line there, and we got them lined up. Now we've shimmed the base just slightly, just a little, like a couple layers of paper bag. And so this here is now, we got that going level. And then we take it over and we put it onto these guys, and we got those level. So it would appear we are ready to, first we'll weld these on. We'll tack them in a couple places and just get a decent kind of alignment. And we don't really entirely care if they're parallel this way because that's the axis of rotation and it should be okay. Can make up for that. We'll just do those by eye. So I won't thin this in anything. So we start with just a really light weld, and then we're going to go for the alignment of the base. If you look closely, you can see it. This is not parallel to this. I would have figured that that was put in perfectly square, but actually I measured it off of both the back and off the front, and it's not. That was in there at just a slight angle. Must have been an allowable tolerance, so I mean, it's a weldment, so whatever. So I'm going to stick with my measurement and not let that freak me out. One of the other things that came out really nice is these washers were just a little bit bigger than the diameter of the barrel there. And so they stuck out. So when I first put them on here, they wouldn't sit flat. So I took them over to the grinder and I ground flats on them until they were, even with the barrel. And it worked out perfect because now those don't rotate. Those aren't walking anywhere. And I was able to set them just right. Now I'll give them just a light clamp and tackety-tack. All right, so we have some light little tacks in there. And because there's a gap, we've ground some metal, and we're going to use that just to kind of tack in those tabs again. And, we got another gap on this side, so it's too big to really fill with weld. I'd have to dump too much heat. I mean, I could do it, but dump a lot of heat into the other thing, so I'll just put some tabs in there. Oh, before I go and weld everything into the base, I wanted to reinforce this. There was a gap there, so I put in a piece of angle iron, put in a gusset, and at this point, I'd pretty much welded all of this part to there. So the thing I just realized is that I had never addressed, those were just a rough sawzall, so I got to take the height from here. And you can see that this one is higher. I got to bring it down probably to about here if you compare the two. So this is going to need some grinding before I can weld it on. All right, so I ground those down by hand. And what we're going to do is we're going to mount the blower onto it, and then we're going to set it onto the frame. And what I'm currently doing is I'm going around my garage looking for where I have the absolute flattest segment of concrete. It's not there, and it's not here. All right, so the flattest surface that I actually had was the deck of my trailer, and I just kind of moved the trailer around until I found where it was perfectly level going across that way. Then I could lower and raise it so it was level this way. We've got everything well aligned. We are just on the inside of the frame. And then this one was actually just a little bit more that way, but that's where it looks like it's the best. I'm going to do a couple more measurements before I weld just in case, but it looks pretty good. Doesn't have to be super precise because really all the alignments for the blower and the belt are all self-contained in here. And this is just the drive unit, so it doesn't have to be super precise. Our blade down here, I adjusted the wear pads, so I got the entire blade sitting at a nice scraping flush level. And I think we're ready to tack this bad boy in place. I also replaced that one big bolt that went across with two smaller ones so that I can get them out easy. All right, here we go. All right, we now have the fronts and backs of all of these welded on. The final orientation finally set. We can see You know, I might have cut out a little bit more than I needed to back here, but this is also going to be based on how much clearance we have when the blade is up. So, you know, I think it's okay. Plus, I mean, I can put that metal back in if I want. I have the pieces. But this also gives me room to work in here. And that could come on pretty handy because inside here, we're actually going to mount the linear, well, we're going to try to mount the linear actuator to make it tilt the back and forward and have it hidden under there so there's nothing extraneous sticking out. All right, so before we get much farther along, I'm going to put in just a little bit of reinforcement here. I'll put in a plate there and then another one back here. That will help to make this mount. It'll help to take the tension and instead of just this little bit of a square, just kind of spread it out over a little bit more frame. Might have been nice to put a plate underneath it when I was going. Might have taken care of some of that gap that I had to fill with the weld. Hindsight, but I was also trying to I was mostly focused on the levelness of everything. So whatever, it'll be okay this way. All right, so we got some more plate in there. That'll help out. And then we're going to devise a little bit of more reinforcement just on the roots of these, just a little bit, because I was welding it with, you know, that other piece around it. So I'll just fill in a little bit more. All right, now in a previous video, we showed you this. This is a linear actuator that we've converted to act as a linear servo for about an initial $10 of parts. Buying a linear servo or a servo with feedback or however you term it, is like at least, you're probably going to spend like 130, 100 up. Another thing we have to consider is now that we're going to be lifting the entire weight of the blower unit and everything, rotating it off of this plate, is this plate strong enough now? I mean, it was never designed to do that. So what I'm probably going to have to do, we already have 2 gussets that I added here, and I continued that across. These 2 tabs are not welded at all, and it's just got some tacks in different places. So I think what I'm going to do is add some extra welds around things, make sure that that's strong, and wherever I put the plate, I'll probably put an actual plate on here, so that it's stronger and tied into the other side of it as well. I'm going to probably also add a gusset right here to give this angle some extra support so that it doesn't tweak. All right. All right, so here is the range of motion that we have. That should be quite sufficient. That'll be, because I mean, right there is level, so that's going to be more than enough. And we have plenty of clearance back here for everything. Now, I've tried, so this thing we talked about earlier, and I built it before I had any idea of this because I wanted to test the code and to make sure that, you know, I knew what I was doing, putting a pot to it and controlling its motion. So it was a success on that front. But as I try to squeeze it in here, even with it all the way retracted, I mean, the linear actuator is okay, but this box is like in the exact wrong spot for trying to squeeze it into somewhere tight. So what do? I don't know. I may try to switch around the mechanism, and I mean, I know the code and the idea works. I may try to disengage the pot from this instead of it being one solid unit and having this based on the motion of this instead of based on the motion of this itself. I'm not exactly sure how that's going to work, if I'm going to try to squeeze it into the side, or if I do it, you know, if I do it on the outside here, I got plenty of room. We got all the room in the world, but it looks a little cheesy. So I'm going to leave that for another video when we get into the electronics. So I'm going to close this video out here just with, you know, blower attachment.